Ever wondered how the takeoff decision speed, V1, is derived? First, you have to understand accelerate-stop and accelerate-go distances. Accelerate-stop distance is the total distance to accelerate an aircraft from a standing start, lose a critical engine just before V1, recognize the failure, and bring the aircraft to a complete stop using idle thrust, brakes, and spoilers. Accelerate-go distance is the total distance to accelerate an aircraft from a standing start, lose the critical engine just before V1, recognize the failure, continue the takeoff to cross the screen height at 35 feet with the takeoff safety speed V2. Now, look at this graph with distance as a function of engine failure speed. The higher the failure speed, the higher the accelerated stop distance required, ASDR, marked in red. This is because it takes more distance to stop an aircraft at high speeds. Conversely, the higher the engine failure speed, the shorter the takeoff distance required, TODR, marked in blue, as it is easier to continue the takeoff when the aircraft is at a higher speed. There is an interception point between the two that requires the least amount of field length required, marked in green, and this is the ideal V1 speed. This V1 speed is also called the balanced V1, as the accelerated stop distance required and the takeoff distance required are the same. In modern aircraft, the electronic flight bag EFB calculates the V1 speed for the pilots to be inserted into the flight management system FMS. I hope you learned something new.